In this video, we're going to take a look at how to multiply rational expressions. And we're going to start with kind of a warm-up problem just to get our minds thinking in the right direction about multiplying fractions. These are not the main problems that we're going to take a look at. And so if you're looking for the ones that require factoring, you may want to skip ahead a little bit just past this example. So anyways, let's go ahead and take a look at this one. So to multiply fractions, multiplying fractions is actually easier than adding or subtracting fractions because you don't need common denominators. All you do is simply multiply the numerators together straight along the top and multiply the denominators straight along the bottom and then simplify. So for example, we have 8 times 7, so just multiply your coefficients and then multiply your variable pieces as well. The rule for multiplying bases is to add the exponents together, so I'll have x to the 7th power and then y to the 4th power. If this feels familiar to you, that's good. It should be. We've done problems like this in the past. Do the same along the denominator. Just multiply straight along the bottom. So x and then y to the 3rd power. Now, what we'll need to do is simplify what we can. Because everything's being multiplied together, this is going to be important for what's coming up, we're allowed to cancel. If things are being added or subtracted, we could not cancel them out. So 56 over 8 can be simplified. That just becomes a 7 over 1. Exponents subtract. That's our rule for dividing with the same base. Or you can think of this as 7 x's in a row divided by 1x. So that 1x on the bottom will drop out with one of the x's, or cancel out with one of the x's on top, so leaving 6 behind. And then y to the 4th become just y to the 1st when it cancels out with those 3 y's on the bottom. So if I make this look just a little bit prettier, in the numerator I've got 7 x to the 6th and then y to the 1st all over just a 1. So I guess I don't even really need that 1 on the bottom. So there is my simplified answer. Now, like I said, that's not our main problem. Here's what our main problems are going to take a look like. So let's figure out what to do with one of these. When simplifying an expression like this, the biggest thing to keep in mind is that we cannot, I repeat, cannot simply cross out the x squareds. People see that x squared in top and bottom and they want to cancel like we did in the previous example. However, the difference, the very important difference, is that x squared in this is not a factor. Because there's a plus or minus sign attached to it, that makes it a separate term. Terms cannot be canceled, factors get canceled. And so the very first thing we need to do in any of these problems is always factor first. Don't try to do anything until the numerator and denominator have been factored. Okay, so let's take a look at how to do that. In the top, we have a trinomial. I'm going to figure out what multiplies to negative 15 and adds up to negative 2. If you need a refresher on factoring, maybe go back and watch one of my previous videos. The two numbers that do that would be a negative 5 and a positive 3. So I'm going to factor this into x minus 5 and x plus 3. And then, rather than rewrite the problem, I just like to factor above or below it and then cross out what I just factored. In the denominator, we have the difference of two squares. You may recall that to do difference of two squares, we simply take the square roots of the term, so x and 3, and the only difference between the parentheses is one is plus and one is minus. So once again, I'll cancel out what I just factored. So now that everything has been factored, now is when it's okay to cross things out. So I'm looking for common factors in the top and bottom, and what I see is that there's an x plus 3 there and an x plus 3 there, so I can cross those out. In the top, all that's left then is x minus 5. I no longer need the parentheses, so I can drop them, although it's not wrong to keep them. In the denominator, I have x minus 3. That is my answer, although once again, it's very tempting for people to want to cross that x out. Think of a plus or minus sign like super glue, and it locks that piece in place, so you cannot cancel things that have not been factored. Here is the main problem then that we're going to take a look at. So it combines kind of the first two things. Unlike in our first example, we are not going to begin by multiplying straight along the top. That's going to make the problem much harder to do and much more complicated. So instead, we're going to factor everything first. And so at this point, why don't you go ahead and pause the video and factor 3 of those. This piece down here can't be factored, or we could say it's already factored. I'm just going to throw it in its own parentheses. So pause the video, factor things, and let's talk about what cancels after that. So that's what I got everything to factor into. Hopefully you had the same thing. If not, like I said, now would be a great time to go back and review one of my factoring videos. At this point, now that everything's a factor, now we can look for common things to cancel out in the top and bottom, and anywhere in the top and bottom, not just within the same fraction. So I see an x plus 3 there and there, so let's cancel out those factors. There's an x minus 5 there and there, so I'll cross those out. And it looks like that's all that's going to cancel. And so what's left in the numerator is this x plus 2 piece multiplied by this x plus 7 piece. And all that's left in the denominator is the x minus 2. Now, there's no need to remultiply those top two pieces together. So I'm going to say that this is my final simplified answer.